What's up, everybody? This is Polynomials video number 6. This one is on graphing. Well, this is actually the introduction to graphing. There's going to be two of them, 6 and 7. This one deals with mins and maxes and other things. So what we're going to do today is define just some basic terms of polynomials, just some basic facts, some items you're going to look for in graphs. So right here, this is no equation in particular. I'm just made up a graph of a polynomial, as you can see, and I want to define some points. So first off, you see these points right there and right there. Those are the tops of these little bumps. These have a name. These are actually called local maxes. So local maxima. Maximum plural, maxima, kind of like cactus, cacti, kind of thing. That's these 2 points right here. So in their areas are the highest points. So this point right there, at the bottom of this valley, you can imagine that it's called a local minimum. So I'm just going to put local min. We have other points. Let's see. This one right here, just like when you graph straight lines in algebra 1, that's the y-intercept. Okay, that's where the graph hits the y-axis. That's the x-axis. So we also have this point here, this point there, this point here, and this point there. And these 4 points are all called x-intercepts. After I hit the x-axis, I ran out of room there. And they're also called roots. You might hear that term more often in this chapter. And they're also called zeros. And then also, so those are the important points. So when you graph polynomials yourself on like graph paper, you're going to have to figure out all these points, plot them, and then kind of trace around it. But also, this point right here, it's the highest point overall. Look at the entire graph. This is the highest point you get. This is also called the absolute maximum, because it's absolutely the highest point in the polynomial. Is there an absolute minimum here? There is not, because since I go down in both directions to all the way as low as you can think, negative infinity, then there is no absolute minimum. Whoops. No absolute minimum. Hit the arrow there by accident. So there we go. So that's the important information. We'll have a couple examples of how to find that right now. So for example, let's say you want to graph the equation y equals 5x cubed minus 3x. So what I can do here is use a grapher, that being a calculator, or better yet, your iPad, or computer, the Desmos calculators. I'll show you in a second. You want to look for these things to graph it correctly. You want to be nice and neat, not just sketch a shape and go quickly. So what you can look for is look for all your roots or zeros, right? The x-intercepts. Find all those and plot those on your graph. You'll see zero spelled with an E or not an E. They're both fine. Also look for your local and absolute min and max. Look for all those points. You want to plot those points on your graph. And also, of course, the y-intercept. You want to plot these points on the graph. That way, you can then trace the graph around those points or through those points, like connect the dots, and make it nice and neat. So, with this one here, I graphed this one on something called the Desmos, so D-E-S-M-O-S calculator. You can get this online at desmos.com, or if you're on one of my iPads, there's a Desmos app. When you do that, here's what I get. So here's the screen capture on my iPad when I had this function graphed. So you see it right here. The y equals 5x cubed minus 3x. It's graphed on this picture right here. What's nice about this is it's basically the Google Maps of graphing calculators, in that I can use my fingers and zoom in, zoom out. 2 fingers. I can drag my finger across the screen, move things left and right. On a calculator, it's a huge pain to have to move things around. So anyways, I graph this, and once I do, you can literally just tap on points, and it tells you what the important points are. So like with my finger, I can just tap on I can just tap on these points here, and it tells me what those points are exactly. You see decimals, they're rounded here. So like, negative 0.447, then 0.894, the other one there, just the opposite. Those points are my local max and local min. So that's my local max. I'll put LM for abbreviation. I shouldn't do that. Local max and then local min. And so what's cool about this is, again, you just tap your finger, and with the calculator, there's a whole bunch of steps you gotta do to figure it out. Also, I can tap the intercepts, the x-intercepts, the zeros, and get those points exactly. So what you see here are screen captures from my iPad of me just tapping my finger at all three x-intercepts, or the roots, or zeros. So each one of these, so 0.775, 0, and negative 0.775, these are all my zeros. These are also what you call roots, like I said before, x-intercepts. And by the way, the graph, or the equation, was y equals 5x cubed minus 3x. Well, you should notice that it was x cubed, and there's 3 zeros. That's no coincidence. Usually the highest power, so your degree of the polynomial, will tell you how many zeros you have, or at least the maximum amount of zeros you'll let you have. So I could have had less than 3 zeros, but that's the most I can have. So if you have like a y equals 3x squared, that's squared degree 2, you can only have at most 2 zeros. And last thing with this graph, notice that it starts from the bottom, from negative infinity, comes up, comes down, and goes back up to positive infinity. So it has no floor and no ceiling. So there's no absolute max or mins here. So with this graph, there's no absolute min or max. So if I was going to graph this myself and actually sketch the curve of this, I would plot the local min, local max, so these points right here on my graph paper, just plot those dots. I'd plot the dots of all three of these, the zeros, and then based on those, I kind of have my important points, then I can just, as best I can, trace the curve around it. So that's just a quick intro how you graph polynomials. No matter what polynomial you use, you can use this app, this program, or this website. You can just go to that word decimals.com if you're at home or on a computer, and you can graph things this way. If you want to use your graphing calculators, I can show you in class. Just ask me, again, how to do that. We've done it before, I think, but if you want a refresher, which I'm sure you do, just ask me in class. Anyways, that's it for this video. I'll see you at the next one.